All right, here we are to try to develop the model of the supply and demand model of a tariff. So I've given you some axes here. Follow along with me and let's see if you can't do this. Starting with price and quantity. What's the supply and demand for, let's say, suppose it's shirts that we're going to end up having a tariff on. The only trick here is we're going to have to draw a supply and demand equilibrium so that if it was just supply and demand and just the U.S. supply, U.S. demand, that the price would be pretty darn high. So let's draw a supply and demand equilibrium, supply and demand curves with an equilibrium that gives us a very high price. Okay, there's a supply and demand that's going to work for our purposes. Now, you're tempted to draw in a equilibrium point here, right? And call this the equilibrium price, balancing supply and demand. Down here, there'd be an equilibrium quantity. But we're not going to draw those in because that's the situation that would occur if the U.S. were unable to import shirts. The key step we're going to do here is recognize that the whole point of importing is that the rest of the world, somewhere out there, can produce this good at a much lower cost using less resources. So let's indicate the rest of the world's comparative advantage by drawing in a price and a supply curve, frankly, of shirts coming from the rest of the world. Let's add that to our model. Here we go. Actually, let's do it live. Here we go. Notice I'm going to put it on this line so I can draw it nicely. Draw across here. Rest of world. ROW providing the shirts. All right, let's think about how the availability of shirts to be bought from or sold to, frankly, the rest of the world is going to give us an equilibrium in this shirt market. What I want you to think about drawing in is what's going to be the quantity supplied, what's going to be the quantity demanded, and we're going to find that the quantity demanded is greater than the quantity supplied to give us the imports. 3 things to identify. Give that a try. Okay, to model imports, we need to recognize the rest of the world's price will enable this quantity demanded. QD0, initial quantity demanded. Okay, so the point is that the rest of the world is supplying these shirts. I gotta move things a bit. Rattle, rattle. Supplying the shirts at that price. There's our quantity demanded. Now, the U.S. producers want to sell shirts, and they're happy to sell shirts in response to this price. Call this PW, the rest of the world's price. And that gives us this quantity supplied. And this difference here, QD minus QS equals imports. And you could make up numbers here if you wanted to, right? Maybe this is like 40,000 and maybe this is 100,000 shirts per year being imported. All right, think about that. Does that make sense? All right, there's our free trade equilibrium showing imports. I'm going to draw this line across here to emphasize the notion that the rest of the world's supply of shirts is acting as a price ceiling. Might not be obvious, but I hope it makes sense that the opportunities to buy shirts from the rest of the world means that consumers will simply order their shirt and they're happy to get it either from a domestic producer or foreign. All right, so question, what happens with a tariff? Why don't we suppose that these ticks represent $10, 10, 20, 30, so $40 price of shirts. We're thinking of kind of 20th century values here. Oh, didn't get that $40 in. There it is, 40. Good enough. Let's suppose there's a $10 $10 tariff. What's going to happen? Well, you can still buy shirts from the rest of the world, but $40 plus 10 gives us $50 as the price of shirts. Coming across here, there's our quantity supplied, there's our quantity demanded. Quantity supplied increases. That's your protection. Protective tariff, increasing quantity supplied. Now, consumers in response to $10 more per shirt are going to reduce their quantity demanded. Those two changes in quantity supplied and demanded give us imports decrease. Let's throw some numbers in here that make sense. If that was 40 and that was 100, maybe that's 45 and maybe that's 95. Imports equal 95 minus 45 is 50. Whereas the imports previously had been 60. So, as we've modeled it, 5,000 more shirts being produced, 5,000 fewer shirts being consumed gives us 10,000 fewer imports, down from 60 to 50. Okay, the only thing left to do to model the tariff at a simple level is to identify the tariff revenue. And if you think about it, distance here is your imports of 50,000. Those 50,000 are each going to generate $10 of revenue. Let me write that down a little more clearly. This is the tariff revenue. Tariff revenue equals $10 per shirt times, we're saying 50,000 shirts equals $500,000. Maybe we're thinking this is something that happens on an annual basis. The process is annual. And what we see is an increase in domestic price because of the tariff, government collecting the tariff revenue. And that's the nuts and bolts of the imposition of a tariff. One final extension to do is to consider the trade-off between potential trade-off between revenue and protection. Think about big tariff that takes us all the way to here. That's, in our little model, a $70 price. So $20 per shirt of tariff. Notice there, imports have been reduced to this very small amount. And it's quite possible that that red rectangle of revenue is now smaller than the original green one. And certainly, if we thought about an even higher tariff, we could come close to cutting off the imports. And as the imports shrink, we're talking about less and less revenue. Okay, let's redraw that and we'll do the analysis of the winners and losers associated with this tariff. Pausing. Okay, I've redrawn this so that we can focus on the effects of the tariff. Let's try and run through the same analysis that you'll see summarized in the web page file, and I'm hoping that doing it step by step will make it clear to you. We want to focus on the key point, which is that we move from this point to this point on the demand curve. And that reduction in consumption is really the basis for everything else that happens and is important, or at least half of it. What we need to think about is how, because of the higher price, a smaller quantity of shirts is going to be demanded. And that's reduction in the quantity of shirts that is demanded and consumed involves a loss for the consumers. Specifically, this little triangular area here represents consumers' loss from reducing their consumption of shirts. We've modeled it, we've said 5,000 fewer shirts per year. This little triangle, we're going to call it, I think it's area 5. Let me have a quick check and make sure it's area 5. Yeah, it's area 5. That is area 5. You'll see in the notes that's described, and it is the loss of consumer surplus, consumer welfare, from the reduction of their quantity demanded. Now, looking back, the other part of this area I've shaded in green is also a loss to consumers. But importantly, this represents the amount of money more paid, the greater amount of money being paid by the consumers for the shirts they're still buying. So that here is, we said perhaps $10 is the tariff, so $10 more per shirt. And this $10 is being paid on all the shirts. So just think about how they're paying $10 more for shirts, and that money is a loss from the consumer's point of view. We're going to end up breaking that area into a series of areas, but right now I want you to just emphasize to the best to the extent you can in your head the notion that this area that I'm shading in this lovely green highlighter color, that area represents the dollar value of what consumers lose from the tariff being imposed, pushing the price up by $10 per shirt, in response to which they cut back their consumption. Okay, next step is the positives. All right, consumers lose, but there are some winners in this situation. Winners and losers is the whole point. Now, what you want to first think about is how these imports that are still occurring, in our arithmetic model, we said that this represented 40,000 shirts. Those 40,000 shirts, each one of those is having $10 paid on them. And that gives us this blue area, which I've also labeled as M times T. We're going to call that area 4, and that area 4 represents the government's tariff revenue. That's something that is being lost by consumers or paid by consumers. It's the negative for consumers, but it's a plus for the government. Okay, let's label that area 4. These numbers go along with the graph on the website. Area 4, this rectangle representing the government's tariff revenue. Okay, the final piece of the winners or pluses situation is to notice that the suppliers go from supplying this quantity at the price of, I think we said $40. They get paid $10 more, in which response to which they increase their quantity supplied. We said it went from 40 to 45. Well, you might remember from microeconomics that when you increase the price and increase quantity supplied in response, you get an area of gain. The area of gain to producers is this two-part area. That area in total is their gain. We can split that into two pieces because in part what's happening is even if they just continued supplying the same 40,000 shirts per year, the fact that they're getting paid an extra $10 gives them a gain, $10 per shirt more for making those shirts. Now, we come here and we see the area above the supply curve. We're going to label this area number 2. That's a slightly more challenging gain to interpret, but it is simply the gain to suppliers from increasing their quantity supplied. You want to think it through. You could see how the increased quantity gives them both an increase in their revenue. Every one of these additional shirts is going to be sold for the $50 tariff price, giving you a tall rectangular area of enhanced revenue. However, we need to recognize that most of that increased revenue is offset by increased costs. And the increased cost of production associated with the increased production leaves only that little area 2 as the actual profit accrue from the increased quantity supplied. All right, so that gives us then the areas 1, 2, and 4 as gains, either to the producers of shirts or to the government, against which we can compare the reduced or losses of the consumers. And what we'll see, of course, is that there's one other little triangular area right here on the graph. It's labeled area 3. And that area 3 is a loss from the consumer's point of view that does not get gained by anybody else. So notice what we've got is we've got these blue areas of gain to somebody, counterposed against the bigger black outlined area of consumer loss. And the point to try and see here is that we end up with what we call net loss, overall loss, or social loss. This area 3 and this area 5 represents, or are, losses that the consumers suffer that are not gained by anybody else. And so they are just losses. We often refer to them as deadweight loss because they are sort of a deadweight on the economy. Anyhow, that's our supply and demand analysis of a tariff. Might not be easy, might not be interesting, but there it is. That's it for now. Good health and goodbye.